what's going on, everyone? I'm Will Button. This is DevOps for Developers, and in the last video, we set up our project and created our issues on our project planning board in GitHub, so we're ready to write some code, right? Well, not so fast, because with every new project, there's a lot of setup and prep work you have to go through to get everything ready before you actually start writing code. Things like, starting off, what language are we going to use? I'm choosing to use Go, but we could have also used Node.js or Python or Ruby or Java or any of a ton of other languages to choose. So that's a choice that has to be made, and it's a choice that affects everyone on the team. And then once you decide the language, you got to decide on how you're actually going to build it. For example, this is our backend API server, so we need an HTTP server in there. And since we're using Go, we could have used Gorilla or Mux or written something ourselves. And I'm choosing to use HTTP router, which adds a dependency to our application. And so there's this whole list of things you got to do just to have your base API up before you can even start writing your business logic. And a lot of times what you'll see with teams is whenever a new developer comes on board and gets ready to start contributing to the code, in a best case scenario, they have a README or a checklist of all these things to do, download this package, download this dependency, install this, use this config file, type these values in this file. And it's this really long drawn out process. And there's actually a metric that is tracked by a lot of high-level organizations on how long it takes a developer to start writing code to a new repo from day one. And most places measure that in the number of days. But I don't like that. I think we can do better. I like to measure it in minutes because my rule is one command. When a new developer joins the team, they should only have to type one command to bring it up. So that's what we're going to set up here. So all you need to do to start contributing to any of the projects I've built is have Docker running on your system, and then check out the code and run that one command. And I should probably clarify, by checkout, I mean a git checkout. Damn, did you see the README on that? I'm not gonna lie, man, that git ignore means nothing to me. Well, I'd compile that binary all night long. Come on, guys, it's code repository, not a sexual object. It's JavaScript. Everything is literally an object. Yeah, so git checkout. But let's go see how we build this. I've got some stuff set up in here already. A lot of this will become clear as we work through this video. Some of it we'll do in future videos. But for now, let's just come down to our development section, and we're going to do #. We're going to call this command dev/init, which is something I like to do, a kind of namespace my make command, so you know what environment or what area you're focused in, and then what the actual thing you're doing is. So for this particular command, for our dev environment, we're going to initialize it. And so we'll give it some help text here, initialize a new development environment. And then, okay, so let me explain this. This line right here is our help text. So if you just run the make command in this repo, it shows you all of the available commands. So it will show you that there's a dev init command and then give you this text telling you what that command does. And that's provided by the help command up here. And you can see that it will just print out usage, colon, a new line. And then we use the sed command to search for those double pound signs. And then we just split that up on the colon and some more sed stuff there, right? All right, good times. Next thing we need to do is give it a phony argument, and that's for dev init again. Now what phony does, if you are familiar with Makefiles and the make command, it was originally built for building and compiling software. So every command that you give it here in your Makefile, it actually looks for those files to compile on your system. By giving it the .phony directive here, we're telling it, hey, this is not a real file on my system, just do the stuff written right below. Because what will happen there is if I actually do someday end up with a file called dev/init in my repo, whenever you run that make command, it will actually try to compile that file instead of doing what we want it to do down here, where down here equals, we're actually going to give it the command now. So dev init, the first thing we're going to do is just going to echo out a little bit of text here, say initializing a new environment, just some feedback for the user. And then we're going to run our Docker command. So we're going to do a Docker run with the name of Postgres, give it some environment variables. So we need to give it our Postgres user, and that's going to be equal to API. Another environment variable we want to give it is our Postgres password. And that's going to be the super secret password of password. Again, that's okay for this instance because this is just running locally for our development team, right? Would not do that in anything that's deployed somewhere. And then we also want to give it a Postgres DB, which is going to be the name of the database that I want it to build. And that's just kind of a handy little feature of Postgres. If you give it an environment variable named Postgres DB, whatever you assign to that variable, Postgres will create that database for you automatically when it launches. So we need to expose our ports. 5432 is going to get exposed to 5432. And then we're going to daemonize that. And the image we're going to run is called Postgres. All right, cool, good times. So that's going to take a second for that to come up, possibly, depending on what kind of computer or how powerful your computer is. So we're going to tell it sleeping for 5 seconds. Again, just providing feedback to our developers here. And then we're going to actually give it the sleep command with the parameter of 5, so it actually does sleep for 5 seconds. And that's just so that, like, if once your Docker container launches, if it takes it a second or two to create that database and reach steady state, that this doesn't fail. All right, the next thing we need to do is install our migrate utility. So migrate is the tool that we're using to manage our database migrations. Whoever's working on this may not have it installed, so we're going to go ahead and install it here. And then once that's installed, we're going to run the migrate command. So migrate-path is going to be migrations, .wac migrations. And if you actually look at the repo here, there's a folder called migrations. That's where we keep our database schema migrations. And then our database URL is going to be Postgres :whack API password at localhost, because we are running that from our Docker container up here on the database trustified. And then we need to specify SSL mode is equal to disable, because we don't have SSL set up on our Docker container, and we're not going to bother with setting that up. And then finally, up, which just tells the migrate command what it's supposed to be doing, and that is running the up migrations. All right, so if all went well, we're going to echo out another statement here. don't know why I keep using the word initialized. I can't spell it. Let's follow it up with another word I can't spell. Okay, so initialize successfully, and then they'll need to launch the API using the command make run/API, which is right down here that just runs the go run command. Or if you're using Golang like I am, you can just click on the little green triangle up here to run it from within the IDE. All right, so make sure I covered everything here. We talked about the help file. We talked about what phony is. We built our script. One thing to note here, if you look at this, when I move the arrow key back and forth, that's one jump there. Makefiles are specific. They will only work on the tab character. So if I had 4 spaces here, which in a lot of environments is equivalent to a tab, this Makefile would not work. It has to be the ASCII tab character. Is it ASCII or is it ANSI? Whichever one it is, it's got to be a tab. All right, so cool times. Let's run down here, go down here, and let's type make dev init and see if this works. Dun dun dun. So our Docker container ran, our go install for running and migrations is done, and that looks like a success message. Not gonna lie, that's pretty dang cool. Let's go over here to our database and refresh this. And if we look, here is our Trustified database with our tables that were built by the schema migration. Yeah, so that looks pretty cool. Now that's done, we're almost ready to open up our first pull request on this environment. And opening up the pull request implies that we need to start doing some CI/CD type stuff, right? You can't just merge whatever into the main branch without kind of doing a few checks on it. So let's set that up. And in my repo, I've got my .github folder. So I'm going to create a new file in there. And that's going to go in the workflows subfolder. And we're going to call this audit.yaml. We're going to give this a name, and we're just going to call it audit because it's kind of what it's going to do. It's just going to audit a few things for us. And we're going to tell it on push for branches of main. And then also on pull request branches main. So what that's saying is it's going to listen for specific events. On a push to the branch main, it's going to run whatever we put in this file, or on a pull request to the branch main, it's going to do whatever's in this file. And so let's tell it what to do. So we're going to give it some jobs here, and our audit job runs on Ubuntu 22.04. We're going to give it some steps. The first step uses actions/checkout at v2. I think that's right. Let's actually take a look here real quick because that might be up to v3 and I don't have anything in there. Okay, never mind. We'll go with it. So the first thing we need to do is set up go. And it's going to do that with the actions setup go v2 with go version 1.18, which is what we're using. Is that right? I think that's right. Let's check and see. Go version, yep, 1.18. All right, so our next thing that it's going to do is verify our dependencies. And we're going to do that with a run command of go mod verify. The next thing we want to do is build our application. So we're going to run go build -v.whack ... After that completes, run go vet to vet our code. So that's going to be run go vet.whack ... And if you're not familiar with Golang, this .whack ... just tells it from the current directory, go through it, and all the subdirectories you find in there, just keep chewing through them. So after we run our vet, we want to install static check, which is going to do some it's going to do some like code linting type checks for us. And we get that from honf.co/go/tools cmd static check at latest. And then we got that installed, so now we can run static check. Again with the .whack ... And then the last thing we're going to do is run our test to make sure that all of our tests pass. So we're going to do that with the go test command with the race flag to check for race conditions. Vet is going to be off because we've already done that. And .whack ... All right, so let's kind of run through this real quick. We talked about what this does. So when one of these conditions is met, it's going to run these following jobs, which we've only defined one. That's the audit job. And it's going to do the same, these steps. It's going to check out our repository. It's going to install Go version 1.18. It's going to run go mod verify to verify our dependencies. It's going to build our application to make sure it builds successfully. It's going to run vet. Then it's going to install a static check and then run static check. And finally run our test to make sure that all of our tests pass. And if any one of these steps fail, then our pull request is going to acknowledge that, and we'll double check. But I think if I set this up correctly, our repo will not allow this pull request to be merged if this fails. So let's merge this in and see how we're doing, kids. We've got our Makefile that we changed. You didn't really see this, but I added the initial DB scripts. We'll do a lot more DB work in the coming videos, so I'm not going to focus on that right now. And then we're adding our audit.yaml file for our commit message, setup initial dev environment. We're going to commit and push. So if we look at our project board, in progress, I have the API number 1, bootstrap our API. It says with Pulumi. We'll talk about that before I wrap this video up because that's just not happening. But let's go check out our repository. So we'll go over to the organizations and this organization, find our API, and look at that. It says, hey, you got a pull request. So we'll do a compare and pull request, local dev environment, description, adds initializing a new dev environment for local dev work. And it also adds GitHub Actions for CI CD. It fixes issue. Actually, it doesn't fix it. It closes number 1. And see here, this, I wanted to show you this. I'm glad I just accidentally typed that out. So I said closes number 1, and it started popping up a list of all the open issues I have in this repository. So I can click that one, and we're going to come back to that. We need to go through our checklist here. We didn't really do anything with logging statements. We didn't write anything with code, so we don't have any tests. Same thing, we don't have any metrics that we're exposing from this. And we didn't do anything for our API endpoints, so that's NA. This was InfraWorks, so there's no seed data. Infrastructure code updated to reflect requirements. Yeah, I think that's done. So now let's create our pull request. And now look at this. We've got our audit actually running right here, and we're going to see if it works. Also, take a look at this. Remember I said we wanted to verify that. Can't merge this right now because we still have this check in progress. Let's go see what that's doing. So far we've got check, running all tests. Ooh, look at that. All of them completed. Big old green check marks. So let's go back to our pull request. Take a look at this. And now I still can't merge this because it is set up for review, but I'm the only person here working on this. So, I mean, I can review my own code. Let's actually do this. Files changed 36. Set up initial development environment, initial commit of skeleton API. Our checks are completed. So this is the audit file that we added. Added some stuff for git ignore. Here's the Makefile. Oh, that's the entire Makefile, so I never actually committed that. As well as, oh, you know what I did? I put all of my Bootstrap files in here. I thought I'd committed that previously. So here's a really bad example of how to do pull requests. I've got two things going on in this pull request. One was added my Bootstrap code for the API, and then I did some work on it too, which this probably should have been two separate pull requests, but here we are. Yeah, so this is all the Go code. All right. And I didn't actually write any of that. I copied it from an existing application. So let's go back over to our conversation here, and I'm going to merge this without waiting for requirements to be met. Confirm that merge. That's merging it in. So another little tip here, this branch has been merged into main, so we can delete that branch. We don't need it anymore. Anything reflecting that is going to be reflected in our Git history. If we go back over to Actions, we're now running that audit on our main branch. So that should work out successfully for us. And then the other thing I wanted to show you with this, let's go back to our organization here, to our projects. This may not be updated yet. Oh, it is. So now I just came back here, right? But look at this. Our ticket number 1 is no longer in progress. It's automatically been moved over to ready to deploy and given a purple check mark showing that it's merged in. And that's pretty sweet, right? Because I know a lot of times I'm really bad about going back to the project board and changing the status of my tickets. But because I tagged the ticket number in my pull request, whenever that pull request got merged, it automatically updated the project board for me. I kind of like that. That's super cool. So if we review back what we did, we now set this up so that a new developer to start contributing to our code base just has to check out the code repository. They need Docker installed, and then they're going to run the command make dev init, and that's going to bring everything up for them. You saw it. It takes a minute or so to happen, and now they're ready to start writing code. One thing I wanted to touch on here is I mentioned in there that I copied a bunch of code, well, not a bunch, I copied some code from a previous project I had into this one to kind of bootstrap it, right? Because I mentioned at the beginning of the video that we're using Go, and the HTTP server I'm using is HTTP router, and we've got some user endpoints and some logging, and there's just a bunch of stuff that I've written a bunch of times before that we need in this application to make it work that has absolutely nothing to do with what the application is going to do. right? This application is for tracking and auditing someone's technical skill set. That has nothing to do with writing HTTP server logs to CloudWatch logs or with monitoring the performance or the speed of the API endpoint, but that's still stuff that we've got to have happen. So I used some code I had written before. A couple of the other ways you can approach this are if you check out on GitHub, if you look around on GitHub for whatever platform you're using, you'll find either they're called bootstrap templates or skeleton templates that have a lot of this boilerplate work set up for you. And I've used some of those in the past and kind of falls into one of a few different categories of why I don't really do that. One is whatever boilerplate or skeleton app I find that seems to do what I want, most of the time brings with it a bunch of dependencies that I don't want or need. And so then I've either got to spend the next 10 years supporting and updating those dependencies to make sure I'm not bringing security vulnerabilities with me, or I've got to take this boilerplate app and strip all of that out manually so I'm not dragging it with me. The other thing that I find with a lot of the boilerplates is that you'll find one that's really set up the way that you think that you want it to be, but it hasn't been updated in a couple years. So your very first step in using this boilerplate app is to do a dependency update, and over the course for however long this thing hasn't been updated, there could be breaking changes. And so you end up spending a lot of time updating dependencies that was probably time you were going to spend just doing it yourself anyway. So for those reasons, I seldom find myself using either a bootstrap or a skeleton app to kickstart my my application. Instead, I've probably got some code that I've written from a previous app, and so I'll just drag that over. It's not elegant, it's not efficient, but it's effective. So that's the way I do it. One last thing I want to point out in this video, because I know we're getting kind of long here. You saw me write the Makefile and then write the GitHub Actions, and everything was magically successful, with no errors. I don't want you to think that that's the way that it's like supposed to be or that it's normal, because the part that you didn't see was all of the time that I spent writing that before I clicked record on my computer, and I would write it and I had typos and syntax errors and couldn't remember the exact syntax of the Docker command. So I had to go look that up and all of this stuff. So I don't want you to walk away from this video with the impression that you're not a good DevOps engineer or a good software developer if you don't write flawless code from the beginning. No, that's not the case at all. I just cut out all the mistakes I made in the video editing process so that you don't have to sit there and suffer through them, because my videos tend to run long anyways, and I try to minimize things for you to watch that aren't actually valuable and leading to your own education. Yeah, I think that's everything I was going to cover on here. So we're actually to the point where we're going to start writing code now. So be sure and subscribe if you haven't already, because the next video we're going to start building out some pieces of our code, which is also going to give us the opportunity to iterate on what we've built here as well, because we're going to be introducing a Docker file when we deploy to staging. So we'll want to do security scans on that Docker file. We also have code dependencies that we're going to be managing. So we're going to want to use Dependabot to automatically check and create pull requests to keep our dependencies nice, safe, secure, and up to date. And so all that stuff's coming up in future videos. So be sure you're subscribed. If you want to see how this all ties into the whole DevOps world, Chingaletti thing everywhere else, be sure and check out the DevOps roadmap, https://devopsfordevelopers.io/roadmap. And I will see you in the next video.